Okay, I'm just talking to myself and without. Okay, let me restart it. Thank you for letting me know. A little bit late though. Okay, so this is a slide for lecture number 10, which is covering the homework assignment number 5. And by the way, you should look at all the lecture after lecture number 10, which is, I think that lecture number 10 is about homework 5. And lecture number 14, 15 is about homework 6. Okay, I assigned both of them. I assigned homework 6 today. So in the spring 2020 version of we have this dumj is converted from JSON to C++, and then from C++ to JSON. And from the JSON to C++, we actually use this function called JSON2Post, which is taking the JSON value object as an argument and return a pointer to the post, class post. So this is the code that was included in the lecture notes, which is, you can see that I'm calling JSON2Post over my v message and then doing dumj to go the other way. So these two lines go both direction. So for this semester, this quarter, that we actually changed that. We actually make it symmetric. So it means that for the other direction, this direction is still the same. We're using dumj from C++ to JSON. But from JSON to C++, we actually using JDump, the function that I start to introduce for homework assignment number 5. So if you look at your hw5 produce.cpp or hw5 merge.cpp, the way it works is that you create an object called post, my post, and then you just say my post.jdump for that JSON value object that you put in as a argument, and this will basically put the content of the JSON into the my post object, and then you can do my post.dumpj, which is basically get you the other side. And I want to tell you that I simplify significantly for homework 5, so you really need to just focus on a couple files. And the rest of them, you can actually see those files as how this two function could have been implemented, and learn from that, you can actually do your own implementation. Okay, so just let you know for your reference, now I'm going back to this is the directory, hold on. This is a directory called, the new one is ecs36b homework 5 F2020 reference. And one of the file, which is the reference, I just gave you this file because I told you there was something called JSON2Post, and that program is actually being included in the JSON_post spring 2020. So just want to show you what. I should get back here. 1 second. So in fact, you don't need to look at this file, but this file just give you some idea about what is what was before the redesign. Let me tell you that why I intended to share this with you is that if you compare this code with the code right now you're designing or implementing, you will see that the complexity of a code is actually get reduced significantly. And this is the concept of object-oriented, because previously I just have one huge function. Let me tell you what that function is. This part is not even the function. This part is just sub-function. You see that here I have something called, oh, this is JSON2. Okay, here is what I call JSON2Post. And inside JSON2Post, if you look at the code, this is just ID part, and then I call JSON post common. Just flash through it, and this is JSON post merge and transaction common, and then this is the major piece of code, JSON post common. And I handle action. You can see here, this first part of the code, I handle the action part, and it's quite complicated. It's a lot of if then else, and then I handle comments, and comments is actually quite complicated. I do all kinds of check. And then this part, I'm handle each of the comment. And then I'm handling each of the reaction. And then I'm handling each of the tags. So you can see that this is a big chunk of code that the handle from the JSON try to extract field by field each of the key value pair in the recursive structure of that JSON, and then try to determine where I'm going to put it into the C++ object. That's what I call the pigeonhole. If you listen to the lecture, I use the term pigeonhole. So the good news for you, I mean, this is code just for you to see a comparison between a previously designed, which I call a monolithic function, is one gigantic function, is trying to handle everything. But now we're actually separate that into JDOM, means that I distribute that monolithic function into each of the class. Post object will have something, comment will have something, reaction will have something. And each of them, they all have two functions. One's called JDOM, one's called DOMJ. And in JDOM, they also recursively call, which I will show you today. So that's basically the homework assignment number 5. I do want to tell you that why we're doing homework assignment number 5. There is a good reason I want to share with you, is that if you can handle the JDOM and DOMJ, if you actually see that this two world of object-oriented information representation, they can do a one-to-one mapping in this setting. You actually can do a lot of stuff with this concept. Let me actually tell you, you can actually, I mean, this is kind of recap about what we're looking at. You can actually talk about object mobility. So for example, you have object that's actually running on your local machine, on your desktop or laptop or your smartphone. And you want to move this object across the internet to the other machine or server or cloud to actually doing exactly what you want to do locally. You want on the fly to move. And this is what we call mobile computing. And this also in object-oriented paradigm, we call the object mobility. And how do I do that? With the JSON RPC you already have, you can actually do that, because what you can do is your local C++ object, or in the future, you're going to local Python project, local your Java project, whatever you want to have, and then you can convert that to JSON. And then you send it over there to your target. Maybe it's IoT device. Maybe it's a cloud computing infrastructure. You send it over there, and over there you actually turn that JSON back to whatever the original object format, and you can continue to execute. So this is basically the object mobility. So there is a little bit different between shadow object and object mobility. Shadow object means that the object is there persistently on one machine. You just use a local shadow. But you could just say, okay, I don't want to deal with the shadow and use the internet. I'm going to take a flight to another continent. I want to load all the objects locally so I can do computation. You can do object mobility. You just grab all the object on your laptop, and then you take the flight without any internet access. You do a lot of object-oriented computation locally. When you land the flight, you reconnect, and then you can actually resync with the real world. So that's something which you can do with this JSON and C++ conversion. And the other thing which is very important is called persistent object. This concept I actually introduced in homework assignment number 6. So what do I mean by persistent object? So far in your programming, that once you create an object in C++, once your program was killed, you control C or you just program ended or segmentation fall, and the object is gone. So next time when you rerun the program, you need to somehow reconstruct that object again. This sometimes is not desirable, because you want to be able to continue what you left last time, and then you continue. So this is what we call persistent object. So what do I mean by persistent object? Means that you're running your program, and at some point you can save it. You can save the program, and then you can run it again. Of course, you can save the program as just bits and bytes in your memory, but sometimes that bits and byte becomes somewhat unreadable. And so means that you look at the file, you don't know what that means because that's a memory layout about C++ object. So a very nice idea about using the dumpj as a persistent object is that before you quit your program, you dumpj every single object that in your system, and such that those objects will be saved as a JSON in the file. For example, this is a file that I save for a post object because this is the post ID and with the class name, and then I save it as a JSON file. So next time when I load it, when I want to run the program again, I don't have to reconstruct everything. I just try to find what was the ID identifier and then locate the file, and I can load it in. I have that object. So this object is called persistent object. It means the object is not going to be disappear when you finish your computation. Okay. So those are the things that's actually very important. And the other part, which is this part, could be a project, the last one. I call it information ownership, trackability or traceability, privacy, or network propaganda. The thing is that when you create a post, like what you have done for homework assignment number 5, it contains people's comment, people's like, and the reaction. And one of the things you might want to know is that, well, who actually have seen my content? It's a traceability issue. And this is an issue, potentially you can actually include all the history about this activity. If this content owned by you, then you can actually use that to set your privacy policy for you to decide how your object that should be propagated. And what we did last year as a homework assignment number 7, okay, you don't need to worry about that this quarter, that we try to ask students to add the history record into every single information propagation, so we will be able to track whether who actually have seen what. Okay. So that was the homework assignment number 5. Okay, so any question? Oh, I know I have to show you something. Sorry, I'm not done yet for homework assignment number 5. I want to show you something. Okay, so this is a reference implementation. You should get this one. If you make, it should works, okay? Okay, but the important thing, which I decide to provide it to you, so you don't need to worry about, is post.cpp. So last time when I distribute, the major difference between last time and this time is that I actually provide you the whole post.cpp. Okay, so let's take a look at post.cpp. Because post.h is a fairly complicated project. It's probably the most complicated data structure within this set of objects. So posts have contained the profile ID, post ID, author, receiver, link, action, reaction, comments, created time, and the update time. So it has a lot of information. I feel that I like you to spend time to understand how post works, but instead you should transfer that knowledge into try to make a comments and the reaction part of that work. And then so you can focus on your final project homework assignment number 6. Instead, I'm actually giving you the post.cpp everything. So you don't have to worry about, so I mean, everything means that I'm actually giving you both the dumpj and jdump for post class as well. So you can see that this is a little bit different from what you had last time. But the first part is just the constructor is basically setting everything. But here is a dumpj. I already give it to you. I think I already gave it to you last time. It basically tried to handle each of the section about the action. You can see that, by the way, one of the things I hope you will follow with this reference implementation is that we repeatedly using the same structure when we want to handle uh, um, certain type of object. If this is a value, if this is a string, I have a one way to handle it. If this is object, like a person, I have a way to handle it. If this is an array, then I have a way to handle it. So for example, action is an array. If this is an array, the structure will look like this. It's always checking whether the pointer is null, whether the size is greater than 0. And inside here is just an array structure about how to use array on a std colon vector, the C++ standard template vector, to actually be able to handle this information. And you can see that it's recursive because it's a dumbj for post, but it's actually calling the action, individual action object, the dumbj. So it's recursively going down that way. Okay, so this is action. If you take a look at the comment is almost the same. You see that is checking the size, and then you have this array structure, and within this array structure, you can see that they're identical. Basically, these two are identical. I'm just calling the comment dumbj. So that's why it's, even though the lines of code might look a lot, section by section, but the structure of code is really the same. I mean, I try to re-implement this using template. I'm not sure that is a good idea, especially it might complicate the readability. The template is a great thing to have, but template sometimes, unless you really know that concept, like a vector, it's a template, is great. But for this type of things, I decide not to use template, but actually using section by section. So make it more readable. So you will have understanding about how this will map to the definition of a class. So this is the dumbj part for comment, and then dumbj part for link. Again, it's the same structure, okay? And then message is a string. Okay, so the previous one, link, action, comment, they're all array. So they share the same structure. And message is a string. So using a string is just putting the content of the string into that. And the reaction, again, is an array. Okay, it's the same structure, but I want to give you a hint that this is actually similar to how you handle array in the comment.cpp. If you haven't figured that out, you can actually take a look at this part of code as well. And again, ID is a different processing, is like a string. Okay, this part is a little bit different. This part is an object. Okay, so author is an object. And then if it's an object, I actually should just call the dumbj for that object and without array processing, right? And again, 2 is also an array. Whenever you have an array, you have this, and then created time is a string, and update time is published. So that's the whole thing about the dumbj for post. So I'm actually going to show you the JDump for post, okay, very quickly. So I actually introduced one function called check post ID. So this function is only doing one thing, is checking whether your ID, like your VS ID or post ID, every single digit is a digit. It's not an alphabet or special character. Okay, it's just try to check whether the ID is correct. Okay, so here is a JDump. And the JDump, I already showed you something last time, but just go over it really quickly. The first part is actually universal for every single JDump. It's checking whether the pointer is null and whether it's an object or not. And then I'm actually checking it better not be array. And now I'm actually checking, because this is a JDump for the post, so it's a lot longer. So the first thing I'm handle for is ID. ID is always, that's why you see that I'm actually checking the post ID, make sure everything is okay, and handle the post ID stuff. And this part of the code is actually somewhat similar how you handle the comment ID as well. Okay, so this part is ID. And again, we have action. Okay, how do I handle action? It's the same thing. I do some check, whether the action is null, whether the data is an array or not. And within here, it's a similar structure. It's a for loop. There's a for loop. But inside the for loop, everything should be very similar, but except there's a one thing, which is I want to cover particularly today, is related to the merge function. Because in the update, I'm just updating one JSON. But in the merge, what I need to handle is that whether this is a redundant information of the information I already have. For example, you already have an action, you already have this comment, you already have this reaction, then you shouldn't add another one. So there is a one section of a code, what you see here is is checking, I call a flag underscore something. In this one, I call a flag AC. It's basically checking whether if the flag underscore AC is equal to 0, means that it's a new one. If it's not 0, means that they're equal. You can see I did a bunch of check, I mean, depending on different section of information. And I actually will say, okay, this one already exists. I just delete it because I don't want to insert a duplicate information. So this part is really for the merge for post. So this is basically for the action part. Just to let you know, you look at this is also recursive, because if this is not, let me see where it is. You see here, this is JDUM. Am I actually calling the JDUM at the action level? Because L action pointer is actually the action object I just created. You see that here I create an action object, and then I just call JDUM to actually dump that object into the action. And if this object is actually a new one, then I actually push back that action pointer into the action array. So this is the handling the array. Again, there is only 3 types of things you need to handle. Either this is a simple type like a string, those kind of thing, or is an array, or is an object. There are 3 types of handling within this type of code. Okay, comment is the same thing. Do a bunch of check, and you have an array. And then if you look at this part, I create a comment object, and then I call JDUM to the comment. Okay, I comment and then call JDUM at the comment level. It's the same structure, but the difference is how do you check the redundancy? They all have to check the structure for redundancy, but the redundancy check for comment is whether the profile ID, post ID, and comment ID, they're all the same. If you have 2 comments, their ID are all the same, means that they're actually the same. You shouldn't insert this into your C++ object. Okay, that's comment. And the next section is the link. You can see that is almost the same. Again, there is a one check if then there are statements here. Message is basically the same. And reaction, I just want to tell you that because I want you to implement the reaction processing in comment.cpp, which I will show you. And you can see that you can actually take a look at this piece of code. It's really similar. Everything is the same. And the only thing I talk to check whether there's redundancy is actually check whether the author is the same for that reaction. Because in reaction, there is no ID. So the only way we can see if we should merge is that we assume, I put it here, I will assume one person can only provide one reaction to a comment or to a post, okay? So you can only do once. So that's what we have a restriction. That's how we check that one. And from is the user ID, and then 2 is again is array structure, and created time, and then update time is published. Okay, so I basically provide you the whole code. You can see it's quite complicated. For first time when you do this kind of programming, it looks very complicated, but it's really a pigeonhole. I mean, the pigeonhole theory still holds. And for each of the pigeonhole, I just need to decide whether this is a string, whether this is an object, or this is an array. And then I will use a similar structure. I'm reusing the same structure, and I will be able to handle all the information. So this code is given to you, okay? But what you need to do is this. So now I'm going to tell you what you need to do. I already write it down for you, so you can tell. You know what you need to implement. So this is a comment. I already have the constructor. Okay, here is the dumpj function. So dumpj function, I already give you some reference code when you develop homework assignment number 4, part 3. But within this code, there are two parts. One is dumj is adding the reaction part, which I assume you already done that, but if you haven't done that, you better finish this. And I actually, for the tech part, you haven't dealt with the tech part, so I provide the tech part for you as well. Okay, the tech part is kind of special. It needs to handle somewhat differently because sometimes you want to tag a person. Logically, is a bit tricky to implement. So that's why I provide it. But for JDump, okay, I provide the checks for you in the reference implementation as I presented last time. This is, by the way, is in the previous version of the reference implementation. And this is handling the ID part. Okay, and now this part, I expect you to handle. How do you handle JDump for handling the author part? How do you actually handle the JDump for the created? How do you handle the message? I actually already include the message. You don't need to even worry about changing this part of the code. But the rest of the part, how do you handle reaction? I mean, it's a structure I provided here. How do you actually finish this part of the code to actually do the JDump? And that's why I said you can actually take a look at how the reference implementation in post.cpp, look at the reaction part and see if you can figure out how to actually implement this part quickly. And again, for the text part, I know it's more complicated, so I actually implement. You can actually see why is it more complicated. Because I have to check, let me actually tell you why. Oh, actually, tag part is not that complicated. It's the inside the tag. Because, okay, now I know why I stuck here. Because the tag is going to call the text JDump. And now I want to tell you what the text looks like. It's complicated because in the tag that you need to decide whether it's tagging a person or it's tagging as a comment. So that's why you see most of this is or, but sometimes I need to have a both or and because it's each case. So because of that, the logic is more complicated. And I hope that you can focus on getting the comment and reaction. So I actually get rid of the tag bar, and then you can just use my code to do that. Okay. All right. So the part of code that you need to implement to get this to work is all being. Let me actually just go up here. It will say, I will say to be completed. If you see this to be completed, if you want to use the reference implementation, I mean, by the way, you can do everything from the scratch, do this conversion if you feel comfortable to do that. But if you want to follow the reference implementation, then look for a place which says to be completed. So the two places I have to be completed. By the way, you should learn how to use grep. It's really useful for you to know what's in there. Is basically this two files. One is comment.cpp, one is reaction.cpp, those two places, okay? So look for those places and try to, I mean, I expect you to do some reading if you want to do the reference implementation because you are going to see how the post object is being handled, okay? Just go back. Okay, so I'm going to pause for a moment. Any question for the new reference implementation or for anything to do with homework assignment number 5?
Professor, I have a question.
Mm-hmm.
So in the Word document, so it's set to test whether the result matched. So there's a line like homework 5 parts my output.json
Mm-hmm.
larger than my output base output.json.
Right.
That line should be homework 5 produced.
Right. That's correct. No, that should be homework 5 parse. That should be homework 5 parts. Let me actually tell you why it is. Let me show you a very quick demo for you to understand a little bit about what that means. Okay.
Yeah.
Can you all see my screen?
Yeah.
Okay. By the way, the other thing I want to tell you is that please use the new output. Okay, use this this output called base input HW5 JSON. I actually fixed one thing within this JSON, so it will be consistent. There is an inconsistent issue for the one of the field. Okay, use the new one. So you can see that. Let me just give you an example. This object looks like this, right? So okay, I'm going to run the program. If you look at /HW5, let me use parse. Let me use parse. Okay, this is this. Let me save it first. If I actually, this is just parsing without doing the JSON conversion. I'm going to call it EE parsed. Okay, so if you look at EE parsed, it's the what we call the to style string format, which is very nice. But the content of this JSON I just produced, the content is equivalent to the base input JSON. So if I do a diff base input JSON and this just do the parse, they will have a huge number of difference, right? So it's not going to be, we're comparing apple and orange. So I'm actually going to run this program again, but this time I'm actually not called produce, I call produced. And I'm actually going to call the function produce. Okay, so this program basically tried to take the base input JSON and convert it to C++, and then call to style string JSON to call the dumpj, and then to create another JSON. So essentially, this two JSON, one is the input, one is go through the conversion process and to form this object called EE_produce. Let's try. So this one is EE produce. Okay, this is the style string output. Okay, how do I know that whether this produce output is equivalent to the original one? If I actually do this, diff base input object and also EE produce, they're going to be different, right? But if I actually compare EE parsed with this, they're the same. You see that? How do I actually generate EE parse? Just to let you know, I'm actually using the HW5 parse. I take the input object, I generate the EE parsed, right? But then I use HW5 produce to take this one, I generate EE produce. So the difference between EE_parsed and EE_produce is that the first one, EE_parse, did not go through the JSON dumpj and JDump process, the JDump and then dumpj process. But the EE produce is actually go through the JDump and then dumpj process. And therefore, if this two output are the same, which show you here, that means your JDump and dumpj conversion is successful. And that's why those 3 lines to tell you that you have to convert whatever you're comparing to convert to the same format so you can do a diff successfully. Does that make sense, Frank?
Yeah, but I think in the Word document, I think you still didn't change it. It's still homework 5 parse.
No, the HW5 parse is just that part. By the way, let me actually interpret maybe I didn't say it clearly, but I think that was just a process I tried to convey, that you should use that program to help you to validate. Okay, this is 5. Let me actually get to 6. Where's the 5? Okay, here. Okay, let me see how I word this part. Okay. Okay, this part, the reason for the following is to validate the equivalence. So the other next 4 line is not try to tell you that this is HW5 produced. Is try to validate whatever you generate from HW5 produced. How do you know it's right? Especially if you have a different format. So the way is, I really want to get the difference. So base input JSON is the JSON I input to my HW5 produce. But my output JSON is the JSON that my HW5 produce output. Okay, so this is the input and output to the HW5 produce. And now how do you actually compare those two to make sure that they're equivalent? So you have to use HW5 parse to convert that to the same format. So you do this convert to base input output.json, and you convert this to this, and then you diff this two. Because if you directly diff this two without doing this 2-step, number 2, 3-step, you're going to get exactly the difference I showed you earlier. So this is not a part of your homework. This 4 line is try to validate whether you have done things correctly. Am I?
Okay, Professor, thank you.
Okay, right. Okay, so I'm going to stop here and then very briefly talk about homework 6. Okay. Any other short question before I